ओके। तो अब तक ये देख चुके थे कि जो बैंड ब्रेक का जो प्रोसीजर था कि सेल्फ लॉकिंग क्या हो सकता है, इफेक्टिवनेस ऑफ द ब्रेक किस किस चीज़ पर डिपेंड करता है, कुछ कुछ कंडीशन था मेरा। नो कुछ ये जितने भी बैंड बैंड ब्रेक था इज ऑल द डिफरेंशियल टाइप ऑफ द बैंड मीन्स डिफरेंशियल बैंड। तो जितना भी बैंड था ये सबका सब डिफरेंशियल बैंड था। नाउ हाउ कैन यू चेंज द डिफरेंशियल बैंड इनटू सिंपल बैंड ब्रेक? It can be changed the differential band into the simple band break is either A or B is mad zero, means either A or B is mad zero. So then become the differential band into the simple band break. So what can be changes is here when A or B in either is mad zero, and what will the forces effectiveness on the brake will be changes when this condition is applied. So now we draw diagrams of the simple bend when this is the one lever, this is a free end of the lever when the force is applied. There is also condition the force is maybe in downward direction, and this is another free end. This is a fulcrum. Okay, this is a fulcrum. Just draw a simple, and this rope is passed over the cylindrical drum. This is center and this is the angle of contact. Okay, contact is the R, and depends on the rotation of the drum. Suppose this rotation of drum is anti-clockwise direction, so this become is a tension T1 and this become is the loose tensions. This direction parallel. ऐसे कुछ डायमेंशन अगर तुम T1 को अगर तुम इधर देना चाहोगे तो T2 को भी तुम इधर देना दोगे, मतलब दोनों का डायरेक्शन एक जैसा होना चाहिए, ठीक है ना, because both applied the same directions for the pulling the rope, and so this is the A. So here is B becomes the 0. In this case B is become the 0, and this is the total length of the lever. So now just apply the moment about this pivot point O, so taking about pivot O. This depend on the force direction. This is a downward direction, just tie to anti-clockwise direction, so F into L. Then this again is try to anti-clockwise direction T2 T1 T1 A, and this is a become 0 because this line action of the line is passes through this point, so distance is become 0, so B is equal to 0, so this force is 0, then 0, then F is equal to T1A by L. This is general equations for the simple band brake. Okay. So similarly the force can be found for the other cases, and not such a brake can neither have a self-energized properties nor it can be the simply the self-locked properties. So this type of the brake has a neither self-locking and not the anodized brake here. So depend on only there are no any ratio of the T over T2, only depend on the A and T. So now if you take another case, or this is the rotating in the anti-clockwise direction. So similarly it becomes, this become is the T1 tight center, this become the T2 center, so all the term will be the same here. So that is a FL and T2A equal to 0. Then again here the F is equal to T2A by L. So again here is the depend on the again A and L and T2. T2 is nothing but the loose side. So this become the loose side. So it depends only one tensions in the belt. So it's this all the differential band or the simple band can be cleared by a numerical. Okay, so suppose I give you a numerical, and how can you solve it as the numericals? Suppose that this question is not asked in the JET, because in JET is not syllabus about the numerical or the differential band, but just I want to clarify that the meaning of the effectiveness of the brake. So suppose that as a differential brake, the question a numerical on the differential numericals. So a differential band. Okay. So the drum diameter is 800 mm. Okay, so it is some condition, a special condition, 800 mm diameters, and the two ends of the band are fixed to the pins on the opposite side of the fulcrum of the lever. At simply you know that how can you see? Suppose that the two ends of the band, okay, two ends of the band are fixed to the pins, okay, on the opposite side of the fulcrum. The opposite sides of the fulcrum, okay, opposite sides of the fulcrum means the fulcrum should be at the midpoint, and the two bend, the ends of the two rope, it's opposite of the fulcrum. Such it is a questions here written here, and just here needs to find out. So the in the questions is written here the two ends of the band. Okay, so one ends, like this is the fulcrum, this two ends, okay, the two ends of the band are fixed to the pins on the opposite side of the fulcrum. This is the opposite side of the fulcrums. So just we going to draw. Okay, just I have a random figure drawing here. Center. This is the angle theta. This is the radius r. And the distance, the lever at the distance of 40 mm to 200 mm from the fulcrum. Suppose there is a sub distance is given, that this is our is given A and B. So suppose that A is given that 200 mm and B is given that 40 mm given. Okay, and the angle of the contact is suppose that the angle of the contact is 270 degree. Okay, the coefficient of the frictions is also given 0.2. So calculate that calculate the brake torque. Calculate the brake torque. Torque when F is the force applied is given that 600 newtons. Okay, but is here it is not any given the direction of the force, in which direction the force is applied, upward and downward. There is no any returns. Okay, this force is applied. The applied 600 newtons at the fulcrum. It's the distance L is the 800 L meters. So L is equal to 800 mm. Okay, so just simply suppose a condition is here, A is greater than B, because A is 200 and this is a 400, the condition. Now but assume the first in the case has to assume the F, in which case is here. So you know that when F is greater than B, then F is should be the downward direction and depends on the clockwise and anti-clockwise directions. So similarly, when A is greater than B and F is downward directions. So just solve it using the equations of our, just imagine this equation. This is our anti-clockwise directions. So this becomes the T1, this becomes the T2. That's all the taking the momentum at this point. We get FL minus TA plus T2 be equal to 0. F is known, L is known, but T1 is not unknown. Therefore, it is calculated from the using T1 by T2 by E this values. So we get the value solving this equations. E 0.2 theta to 70 degrees here, and this change into the radians. 270 pi into 180 degree and just 2.57. So I have gotten this value. Then the put all these equations. So 600 into 800 minus 2.75 T2 into 200 plus T2 into 40 equal to 0. Then calculating the all datas. T2, just solve this equation. T2 equal to 1012.7 Newton and T1 becomes 2602 newtons. Then braking torque. So braking torque, that's T1 minus T2 into R. So solve this. 062.5 minus 1027 into 0.4, which is the radius in meter, and 636 Newton meter. This is the braking torque. When this is the case when drum is anti-clockwise directions. Now when the drum is clockwise, if drum is rotating clockwise direction, if rotate, then the equations will be all the things changes. Just I have discussed downward directions, and this is the first rotations, and then second is clockwise rotations. Okay, then the equations, such type of equations. Then FL plus T1B minus T2 equal to 0, and solve all the equations. Then it becomes the braking torque will be here 101. This is the more torque required. Okay, so this is the more torque required and compared to this equations. So this is the minimum torque required, this is the maximum torque required. This is a more effective in this case. Okay, so therefore I am talking about that why I is going to be when the force is downward and upward, and then if upward, the case will be the subsequent changes. So this is the numerical I have tried to clarify the between the condition and cases. Okay.